At 54 qubits they opened some a molecule, and they could measure it here, observing it in like Silicon Valley or wherever this is. And then they opened the same one, it appeared in London, and they verified that the changes they made in Silicon Valley were happening with it's the same molecule, and it was happening at the same time someplace else. What a recent quantum computer experiment may have just provided is the first real evidence of a parallel universe shifter. The discovery has left scientists stunned, and if it holds up, it could change our entire understanding of reality. For decades, physicists have speculated about the existence of parallel universes, hidden realities that branch off from our own, governed by the strange rules of quantum mechanics. But until now, this idea has remained largely theoretical. That may no longer be the case. A new quantum experiment has recorded something never seen before, an anomaly so bizarre that some researchers believe it could be the first tangible sign of information crossing between dimensions. Could this be the breakthrough that finally proves parallel universes exist? What does this mean for science, for reality itself, and even for the way we experience time? Before we reveal exactly what was discovered, let's first understand why quantum computing might be the key to unlocking parallel universes. Quantum mechanics has long hinted at the possibility of parallel universes, and quantum computing might be the tool that finally uncovers the truth. At the heart of this idea is the many-worlds interpretation, a mind-bending theory suggesting that every quantum event creates multiple realities. According to this view, every time a particle is measured, the universe splits, creating countless alternate timelines where every possible outcome happens simultaneously. This means that right now, there could be versions of you living out completely different lives in realities that are just out of reach. While this concept sounds like science fiction, it emerges directly from the mathematics of quantum mechanics. And now, a recent quantum computing experiment has delivered a strange result that could be the first real clue that these parallel worlds are more than just theoretical speculation. To understand why this experiment is so important, we need to look at three key phenomena in quantum mechanics: superposition, quantum tunneling, and entanglement. Superposition is the idea that particles don't exist in just one place or state, but in multiple states at once until they are measured. This is the foundation of quantum computing, where quantum bits, or qubits, can be both 0 and 1 at the same time, allowing them to perform incredibly complex calculations. Then there's quantum tunneling, a bizarre effect where particles can pass through barriers as if they temporarily vanish and reappear elsewhere, suggesting that reality isn't as solid as it seems. But perhaps the most fascinating phenomenon is entanglement, in which two particles become instantaneously connected no matter how far apart they are. A change in one particle immediately affects the other, even if they are light years away, something Einstein famously called spooky action at a distance. The experiment in question focused on a strange anomaly that might be linked to something entirely new, a possible parallel universe shifter. Quantum computers, with their ability to process vast amounts of quantum interactions, have given scientists an unprecedented window into the deepest layers of reality. In this experiment, researchers were running standard quantum gate interactions when they noticed something completely unexpected. Instead of behaving as predicted, certain quantum states appeared to fluctuate in a way that couldn't be explained by known physics. Some scientists believe this could be evidence of quantum interference from another universe, where information might be subtly leaking between dimensions. True, this discovery could change everything. The idea that quantum particles may be influenced by realities beyond our own would mean that the fabric of existence is far more complex than we ever imagined. Could it be possible that we are already experiencing tiny shifts between alternate versions of our world without even realizing it? Some researchers have even speculated that unexplained phenomena, such as the Mandela effect, the widespread belief that collective memories sometimes differ from historical records, might be linked to subtle quantum fluctuations between dimensions. But what happens next in this discovery is even more shocking, because the anomaly scientists detected wasn't just a random glitch. It followed a pattern, one that could hold the key to proving that parallel universes are not just possible but may be directly interacting with our own. The recent quantum computing experiment that stunned scientists wasn't just an isolated glitch. It was a pattern, something that defied explanation within known physics. Researchers at CERN and Google's Quantum AI Lab were conducting routine quantum experiments testing quantum gate interactions to refine computations. But in the middle of their tests, something completely unexpected happened. The quantum computer registered an anomaly, a fluctuation in the quantum states that wasn't supposed to be there. At first, they assumed it was an error, a hardware malfunction, or even interference from external noise. However, after running multiple tests and isolating every possible variable, they realized that this anomaly wasn't random. It followed a distinct pattern, one that suggested something far stranger than a mere computational error. The anomaly behaved as if the information was appearing from an unknown source, seemingly emerging out of nowhere. This wasn't like normal quantum noise or expected computational fluctuations. Something else was interacting with the system. Some researchers believe this could be the first evidence of quantum interference from another universe. According to certain interpretations of quantum mechanics, if parallel realities exist, there might be moments when they briefly interact, creating small but detectable disturbances. If this anomaly is what some suspect, a parallel universe shifter, then it means quantum computers have for the first time recorded possible evidence of information crossing between dimensions. While skeptics argue that this could be an undiscovered quirk of quantum mechanics, others suggest that this experiment could be revolutionary. If a quantum system is detecting and reacting to information beyond its own computational limits, it raises the possibility that alternate realities are not just theoretical but may be physically accessible in certain conditions. Some theorists speculate that this could mean parallel universes are not separate and unreachable, but indeed exist in a kind of quantum superposition, occasionally overlapping with our reality. If so, what scientists have just detected might not be an accident. It could be a fundamental aspect of the universe itself, a hidden layer of reality we've never been able to measure before. The implications of this discovery are enormous. If quantum computers can detect anomalies like this, could they eventually be used to map interactions between parallel worlds? Could they help us understand whether information, energy, or even matter can travel between these realities? And if so, could we one day find a way to control or manipulate this process? These questions may seem like science fiction, but they are now being seriously considered by physicists trying to make sense of what this anomaly means. But here's where it gets even crazier, because long before this experiment, some of the world's most respected physicists had already predicted that something exactly like this could happen. One of them is Brian Cox, a leading expert in quantum mechanics who has long suggested that if parallel universes exist, quantum computers might be the first tools capable of detecting them. And now, with this latest discovery, his predictions may be closer to reality than ever before. Brian Cox has long been one of the most vocal proponents of the idea that quantum mechanics could reveal the existence of parallel universes. As a leading theoretical physicist, his work has explored the deep connections between quantum physics and the nature of reality, often challenging the way we understand existence itself. Long before this latest quantum computing experiment, Cox had speculated that if alternate realities were real, we might one day detect them through quantum interactions. His argument was simple yet profound. If quantum mechanics is correct, then parallel universes are not just possible, they may be necessary. Cox's reasoning is rooted in the many worlds interpretation, which suggests that every quantum event causes the universe to split into multiple versions, each playing out a different possible outcome. According to this view, we don't experience these alternate realities directly because our consciousness follows only one path through the countless branches of the multiverse. However, Cox and other physicists have proposed that quantum computers, machines specifically designed to harness the strange properties of quantum mechanics, could eventually uncover clues that reveal these hidden layers of reality. What makes this recent experiment so intriguing is how closely it aligns with these predictions. If a quantum computing system has truly recorded an anomaly that defies conventional physics, it could mean that our reality is already interacting with other versions of itself in ways we never expected. Cox has previously suggested that quantum entanglement and superposition might hold the key to understanding how parallel worlds could overlap. If particles can be in multiple states at once, and if entangled particles react instantaneously across vast distances, then what's to say that information from another universe couldn't occasionally seep into our own? Of course, Cox isn't the only scientist who has explored this idea. Many physicists have debated the implications of quantum mechanics for decades, with some arguing that the mathematics of quantum theory strongly hints at the existence of alternate realities. However, what makes this moment different is the emergence of actual data, an anomaly that could represent the first tangible sign of something beyond our current understanding. If Cox's predictions are correct, then this could be just the beginning. Future quantum experiments may reveal even more anomalies, perhaps even patterns that could help us determine whether parallel universes truly exist. If information is leaking between dimensions, it raises the question, could we one day find a way to control this process? Could quantum computing evolve to the point where we not only detect alternate realities but also interact with them in meaningful ways? These questions are no longer confined to the realm of science fiction. They are now being actively considered by physicists pushing the boundaries of quantum research. And if the implications of this experiment are as groundbreaking as they seem, then we may be closer than ever to proving that our universe is just one of many. But this discovery leads to an even more mind-bending question. If parallel universes exist, have we already been shifting between them without realizing it? For years, the idea of parallel universes has remained a subject of speculation, fueled by the abstract mathematics of quantum mechanics and theories like the many-worlds interpretation. But now, with the recent quantum computing anomaly, some scientists believe we may have stumbled upon the first tangible evidence that parallel worlds are real, and more importantly that they might already be interacting with our own. If this anomaly truly represents a parallel universe shifter, then it suggests that information is not confined to a single reality but could be leaking across dimensions in ways we've never imagined. One of the most fascinating aspects of this discovery is its potential link to something that has puzzled people for years: the Mandela effect. This phenomenon occurs when large groups of people collectively misremember details about historical events, famous quotes, or even the spelling of common brand names. Some theorists have suggested that these memory discrepancies could be the result of subtle shifts between alternate realities, where slight differences exist in each version of the universe. If information from another dimension can affect quantum systems, is it possible that it could also influence human perception? Could our minds, in rare moments, pick up on small changes caused by quantum shifts between parallel worlds? While mainstream scientists remain skeptical of such ideas, they do acknowledge that quantum mechanics already allows for phenomena that seem impossible under classical physics. If this recent quantum experiment has truly detected something beyond our known reality, it could mean that parallel universes are not just a possibility but a fundamental part of how existence operates. Some physicists have even proposed that if quantum systems can be influenced by alternate dimensions, then the entire fabric of reality might be more fluid than we once thought. But the biggest question remains: if we are already experiencing interactions with parallel universes, could we one day control this process? Right now, our understanding of quantum mechanics is still in its early stages. And while quantum computers have made incredible progress, they are nowhere near powerful enough to deliberately manipulate reality itself. However, if quantum anomalies like this one can be replicated and studied further, we might be on the verge of uncovering new physics that allows us to not only detect parallel universes but also understand how they interact with our own. If that's the case, then this experiment may be just the beginning. The next step will be to determine whether this anomaly was a one-time occurrence or a repeatable phenomenon that follows a consistent pattern. If scientists can confirm that quantum systems are regularly interacting with unknown forces beyond our dimension, then we may have just taken the first real step toward unlocking the secrets of the multiverse. But that also raises an even bigger, more mind-bending question. If quantum computers can detect this, could they one day be used to shift between universes? And if so, has someone already figured out how to do it? If quantum computers have detected an anomaly linked to parallel universes, the next question is even more mind-blowing. Could we one day control this process? Right now, quantum mechanics allows for strange phenomena like entanglement and superposition, but manipulating them at will is still beyond our capabilities. However, some physicists believe that as quantum computing advances, we may develop the ability to engineer reality itself by influencing how quantum states interact with alternate dimensions. One possibility is that quantum computers could one day be programmed to deliberately access or influence parallel worlds. If information is indeed leaking between dimensions, then it may be possible to redirect or harness this information, allowing us to interact with other realities. Such a breakthrough could fundamentally change how we view the universe and our place in it. But for now, this discovery is still in its early stages. Scientists are cautiously analyzing the data, running further tests, and trying to determine whether the anomaly is repeatable or a one-time event. However, the implications are already clear. If this is the real deal, then we may be on the cusp of a new era in physics. Whether it's shifting between dimensions, exploring parallel universes, or even altering the fabric of reality itself, one thing is certain: the world of quantum computing has just opened up a whole new realm of possibilities, and we're only beginning to understand the true power of the quantum realm.